Next problem. If vector f is equal to, this is del of x y cube z square, then find divergence of f and curl of f vector at 1 comma minus 1 comma 1. Alright, so we know that whatever they have given is a scalar field. So scalar is indicating that this is x y cube into z square, and they already have mentioned that if the condition says that f vector is nothing but the del of this function phi. So what is del phi? This is dou phi by dou x into I cap plus dou phi by dou y into j cap plus dou phi by dou z into k cap. So you can see that directly we can apply the dou by dou x on the phi itself. So when you do that, you get this is y cube into z square into I cap plus we have 3 times x into y square into z square into j cap plus dou by dou z of phi with respect to z. So z square becomes 2z. So this is 2 into x y cube z square into k cap. So this is the given vector f. Now, so the first part of the question is finding out divergence of this. So divergence of this vector f, this is equal to, the general equation notation is del dot f. So that is nothing but this is dou by dou x into I cap plus dou by dou y into j cap plus dou by dou z into k cap dot, let's write the given vector. So the given vector here is y cube z square I cap plus 3x y square z square into j cap plus 2x into y square z square k cap. So we know that from the basics of the vector dot product, I can take a product of I with I only. I cannot take the product of I with something different. So because of that, now we are writing in this fashion. So this is equal to, so this is dou by dou x can be applied to y cube z square only. Next, plus the dou by dou y can be applied to x into y square into z cube. Not z cube, z square, sorry, my mistake. This is z square, okay, plus the next term will be dou by dou z of 2 times x y square into z square, x y cube z square, sorry, that's correct. So this becomes x into y cube into z. Okay, so I'll correct, please make a correction. So this is x y cube into z. We have the same thing here, x y cube into z. So this means first term is 0 because there is no term containing x. The second term becomes differentiation of this function with respect to right? So you know that already there is a 3 present over there, 3 into x into y square. So this becomes 6 into x y z square plus 2xy cube. So we can simplify this and write like this is, let's say we write 2 into x into y, multiply this with 3 times z square plus y square. So we differentiated and we took the common term out of this. So this is nothing but the divergence of the given vector f cap. But you see that in the question they already mentioned that we need to find the divergence at a given point. So therefore the same divergence of vector f at a given point. What is the point? This is 1 comma minus 1 comma 1 equal to, I need to substitute xyz as 1 minus 1 and 1 respectively. So this is 2 into x is 1, y is minus 1 into, this is 3 times z square. So anyway, I'll substitute the value of z as 3 times 1 square plus y square. So y is minus 1 square. So you see that here I get minus 2 into, this is 3, I think there is a square, so this is minus 1 square, so 3 plus 1. So the answer becomes equal to 3 minus 2 into 4 is minus 8. Alright, that is the answer. Then the same question has another part, that is to find the curl. So let's write curl of this vector. Curl of f vector is nothing but this is del cross of the vector f. So del cross can be written in this fashion: I, j and k cap. Below that I need to write the partial differentiation dou by dou x, dou by dou y, dou by dou z. And below this we have to write x, sorry, let's write the vector f itself. And we know that vector f has the first term, that is y cube into z square. Sorry, y cube z square. Next term is 3 times x into y square into z square. And the last one is 2x y cube into z. So we need to take a determinant of this function. Okay, so let's do the determinant part now. So I into, this is dou by dou y of 2x y cube into z minus dou by dou z of 3 times x y square z square. This is the first term. Then minus j into, when I do the minus j, it should be dou by dou x of 2 times x y cube z square minus the dou by dou z of, that is y cube into z square, then plus k cap multiplied by, this is dou by dou x of 3 times x into y square z square minus dou by dou y of, this is y cube into z square. Okay, so this means now we can simply simplify this directly as follows. So this is I cap, multiply this with, so the first term becomes, I am differentiating with respect to y, so 3 into 2, this becomes 6 x y square z minus, so this becomes once again with respect to z, so 3 into 2 is 6 x y square into z. Then I have next minus j cap, multiply that with, so with respect to x, so this is 3y square z square, my first term, minus differentiation with respect to y, so this means 3y square z square, and the last term is plus k cap into, the differentiation becomes 3 times y square z square minus 3 y square z square. So sorry, I think here I made a mistake in the second term, sorry about that. So this becomes 2y 3y cube z. Is it 3 or sorry, it's a 2y cube z. Okay, so this is 2 into y cube z. Let me correct, sorry, this is 2y cube z, this is also 2 into y cube z. Okay, now you can see that every term gets cancelled over here, right? So that means the final answer becomes equal to 0. Okay, so that's the solution to the question. Let's go to the next question. Right. If vector A is equal to x times z cube into I cap minus 2 times x square yz into j cap plus, this is 2 times y into z to the power 4 into k cap. If this is the question, then find. We have part A of the question is del dot this vector A. Then part B of the question is del cross vector A. Okay, and part C of the equation, this is del dot del cross A vector. Okay, at 1 comma minus 1 comma 1. So the first two parts we already have solved this, so this becomes very easy for us to solve, right? So part A of the answer, this is to calculate del dot vector A. So del dot vector A, so the del operator is nothing but this is dou by dou x into I cap plus this is dou by dou y into j cap plus dou by dou z into k cap dot the given vector, so this is x into z cube I cap minus 2x square yz j cap plus this is 2y into z to the 4 into k cap. We need to take a dot product, which means we can multiply only the term containing I with I. So that is dou by dou x of x into y cube plus this is dou by dou y of minus 2x square into yz. Then we have plus dou by dou z of this is 2yz to the power 4. So it's a simple partial differentiation. So you can see that x, say x into z cube, sorry, please make a correction. So this is x into z cube. So my answer becomes equal to z cube. This is minus 2x square into z plus this is 8 into y into z cube is this answer. Okay, but what they have asked is del dot a, right, at the given point 1 comma minus 1 comma 1. So simply we need to substitute 1 minus 1 and 1 over there. So the first term becomes 1. So the second term becomes minus 2 into 1 is minus 2 plus 8 into 1 into this is minus 8. So minus 8 minus 2 is minus 10. Minus 10 plus 1 is minus 9. That is the answer for the first part of the question. Okay. Now, proceeding further, we need to calculate the del cross A vector. Del cross A vector in the second part. This is equal to, so we know that we need to solve a determinant. So that determinant is I cap, j cap, k cap. Below that it's dou by dou x, dou by dou y, dou by dou z, and the terms will be written one by one. So first term is x into z cube. Second term is minus 2 into x square into yz, and this is 2y into z to the power 4. Alright, so now we need to solve this determinant. Okay, so this means this is equal to, so first I write I multiplied by, this is dou by dou y of 2y into z to the power 4 minus, this is dou by dou z into minus 2x square into yz. Alright, then this is the I minus j cap should be multiplied with dou by dou x of 2y into z to the power 4 minus dou by dou z of x into z cube. Then we have plus k cap into, this is dou by dou x of minus 2 into x square yz minus dou by dou y of x into z cube. Okay, now this means I can simplify this as I cap into, this is 2 times z to the power 4, minus of minus becomes plus, this is 2x square y minus, there is a j cap into, so dou by dou x of the first term, that is 0, minus differentiation with respect to z, that is 3x into z square, then plus k cap multiplied by differentiation of the term with respect to x gives me minus 4xyz minus 0. So this is nothing but, I am going to write it in a simplified format. So this is, I can take it 2 outside, so 2 into, this is x square y plus z to the power 4 into I cap plus, next term is 3 times x z square into j cap, because minus of minus is plus. Then I have minus 4 xyz into k cap. So this is the result of the del cross A vector, but exact answer can be provided after we perform the del cross A vector at a given point, that is 1 comma minus 1 comma 1. Alright, so this is 2 into x square is 1 into y is minus 1 plus this is z to the power 4, that is 1 to the power 4 is 1 into I cap plus 3 into 1 into 1 times j cap minus 4 into 1 into minus 1 into 1 into k cap. So you can see that this first term is 0, second term is 3j, last term is plus 4 into k cap. So 3j plus 4k is our answer. Okay, next. And now we go for part C of the question. It says that we need to calculate the del dot of del cross A vector. So del cross A vector is an answer. We already know that. That itself will substitute. Okay, so this is equal to, what is del dot? Del dot is nothing but dou by dou x into I cap plus dou by dou y into j cap plus dou by dou z into k cap dot the del cross A vector we just have found, right? We'll write that. So that is 2 into, this is x square y plus z to the power 4 into I cap plus 3x into z square times j cap minus 4 times x into y into z into k cap. Right? So now we can multiply the term containing I and I. So this means that I have to calculate dou by dou x of 2 times x square y plus z to the power 4. This is the first one. Then plus this is dou by dou y of 3x into z square. Then we have plus this is dou by dou z of minus 4xyz. Okay, so now we can see that the first term I am differentiating with respect to x. So I have 4xy. Then the second term has no y component, so it is 0. And the last term becomes differentiation with respect to z is 4xy. So they will cancel and the answer becomes equal to 0. Alright, so that is the required answer for this particular question. Alright, let's go ahead to the next part of the question. So we have some theorems to prove. First one, this is show that the gradient of vector A dot vector R is equal to vector A. Alright, so we start in the following fashion, right? We have to assume this. We have to assume some vectors. So let the vector A is equal to, this is A1 into I cap plus A2 j cap plus A3 into k cap. Alright, and the radius vector, this is denoted by R. Always we know that this is x into I cap plus y into j cap plus z into k cap. Okay, this is z into k cap. Now we know that vector, if at all I want to write the vector A dot vector R, this is nothing but it's a summation, because I need to take a summation a1x plus a2y plus a3z. We are going to write it in this way itself. Alright, so this means now I take the gradient on both sides. So that is del dot vector A dot vector R is equal to, this is summation dou by dou x I. We already have seen this kind of notation should be multiplied with summation of a1 into x. So you see that dou by dou x of a1 with respect to x is simply a1. So I still get a1 into I plus a2 into j plus a3 into k. So this means it's, anyway, the x cancels, y cancels, and z cancels. So that will be equal to, once again, summation a1 into I. So what is that? Summation a1 into I, that is nothing but it's a vector. So we reached the right hand side of the given function. All right, that's a first theorem we proved. Let's go further. The next theorem is we have to show that this is the divergence of the vector A cross vector R is equal to 0. So we'll start with the LHS. The left hand side is nothing but it is the divergence. Oh, okay. First we'll find out the A cross R. Okay, so only after that we can go to the left hand side. So we'll start from that point. So consider the vector A cross vector R. So from the basics we know that this is I cap, j cap, k cap. First vector comes first, a1, a2, a3, and R is nothing but x, y, and z. This determinant. So if you remember, we already have given a short form for this, that is nothing but summation I into, this is a2z minus a3y. This was the short form which we already have given, right? So this means, so now we'll start with the LHS. Therefore, start with the left hand side. Left hand side is nothing but it is a divergence of this vector A cross vector R. So what is it? What do you mean by divergence? Divergence is del dot, right? So I am going to apply del dot this vector A cross vector R. So that is equal to, what is del? Del can be written as the summation dou by dou x into I cap. This is the summation. Dot A cross R is nothing but, once again, summation I cap into, this is a2z minus a3 into y. Close the bracket. Now you see, if you apply dou by dou x to this, right, it means there is no term containing x, which means it is 0. Differentiation becomes equal to 0, right? So all the terms will be reduced to 0 itself ultimately. So we can simply write this is equal to 0. That is the right hand side of the given question. Okay, very straightforward answer. Okay, now let's go to the next question. Here, if vector R is equal to x into I cap plus y into j cap plus z into k cap, right? And r is nothing but magnitude of this vector, right? If this is the given condition, then we need to show that the del of r to the n is equal to n into r to the n minus 2 into r vector. Okay, so we need to prove this now. So let's prove this. So what we do, we write down what they have given first. So r is nothing but this is magnitude of r. Magnitude of r can be simply written from the given data. It is x squared plus y squared plus z squared. Okay, so this actually implies, if at all I want to write r squared, I can simply write it as x squared plus y squared plus z squared. Okay, let's hold on to something now. So let us differentiate this, because in order to prove something we need the partial derivatives as well, because somewhere we get dou by dou x of this r, right? Because there is a gradient coming. Gradient indicates that you have to perform the dou by dou x or dou by dou y or dou by dou z. So just to maintain that, we will do this. So let's write this. So differentiating partially with respect to x. So let's differentiate this function with respect to x. So this is 2r into dr by dx. Okay, it's a partial differentiation. So let's give a notation dou by dou x. Okay, so this means 2r into dou r by dou x is equal to, on the right hand side I simply have 2x. So 2 will cancel. So this implies, if at all I want to write the dou r by dou x, dou r by dou x is nothing but it is simply x by r. So this is true whenever our given r is equal to x into I cap plus y into j cap plus z into k cap. If that is the case, then dou r by dou x is this, right? Also we can calculate. I'll simply write similarly. Similarly, I can still prove the same thing. The dou r by dou y is equal to y by r, and the dou r by dou z is equal to, that should be z by r. So very similar to the previous case, we can prove this as well. So now we'll hold on to this. Now we'll start with the left hand side. Okay, left hand side of the given question, that is, this is del of r to the n. What is del operator? Del operator can be replaced by summation the dou by dou x into I cap, right? This has to be applied to r to the n, right? So now what I do, I take this summation, right, here and apply the dou by dou x to this term. So dou by dou x is nothing but differentiation of this term, that is n, into, this is r to the power n minus 1, into the differentiation with respect to, that is dou r by dou x into I. This is just I cap. Then you need to proceed to the next one. But I know that this is equal to, the summation remains as it is. This is n r to the n minus 1. Look back. What is dou r by dou x? Dou r by dou x is x divided by r. Already we have proved that. That's why we did it earlier. So into I cap. Now you can see that we can club the terms. This is summation n as it is. There is a n minus 1 and one more n minus 1 in the denominator. So this becomes r to the power n minus 2. R to the power n minus 2 into, right, into x into I cap. Now you see that summation is actually applicable to the x and y. So I write n r to the n minus 2 outside, and the summation I apply to x into I. So x into I plus y into j plus z into k is nothing but that is r itself, vector itself, right? So this means n r to the n minus 2 into the vector r. Okay, so this was the RHS that is given, right? So you can just verify this is what has been asked. So show that n into r to the n minus 2 into that vector r. This is what they asked us to prove. Okay, then we go to the next proof. This is also equally important. So the question here is like this. This is the del square of r to the n is equal to n into n plus 1 into r to the n minus 2. Alright, so this means we directly start from the beginning itself. So LHS is del square of r to the n. So what is del square? Del square is nothing but summation. This is dou square by dou x square. It's a del square. Del applied twice. So del square of r to the n. Right? What I do now, I expand this. This is nothing but summation. The dou by dou x into dou by dou x. Let's split this term. Dou by dou x into dou by dou x of r to the n. Okay, so the first part is nothing but keep the summation dou by dou x as it is. Apply dou by the one of the dou by dou x to r to the n. So what do you get? That is n into r to the n minus 1 into dou r by dou x. Okay, this is what we get. Next part, you can see that I'm simply going to substitute the dou r by dou x there. So this is summation dou by dou x remains at the as an outside term, n into r to the n minus 1. What is dou r by dou x? That is nothing but x divided by r. Okay, now this means this is equal to the summation dou by dou x of n into r to the n minus 2 into x. So I can take this n outside and I can write this term as this is equal to, I'll take the n outside, then I apply the dou by dou x to this summation of apply dou by dou x. When we apply the dou by dou x, this becomes, right, first I apply to x, so x becomes 1, simply r to the n minus 2, plus second term keep x as it is, right, then I apply this, so that is n minus 2 into r to the power n minus 2 minus 1 is n minus 3 into dou r by dou x into x, because x I need to keep as is. This is the differentiation of the term. Okay, once again I have a dou r by dou x, which I know what is this. I know the substitution for this. Let's put the value. So this is n into summation of r to the n minus 2 plus this is n minus 2 into r to the n minus 3. What is dou r by dou x? If you remember, we proved that this is x by r. Okay, into x. So I need to apply the summation. So before that, let's try to keep the terms as simple as possible. So this means this is n into summation. So there is r to the power n minus 2 plus there is n minus 2. N minus 2, you see that there is n minus r to the n minus 3 divided by r, which becomes r to the power n minus 4, and x into x becomes x squared. So this is the most simplified term what we have. Okay, so what we do, we try to expand this. So expanding the summation, because we have to expand the summation, without that we cannot prove the required answer. Okay, so that means let's write this is n times n into, so first term, wherever it remains as it is. Okay, first term is as it is, so that is r to the n minus 2 plus this is n minus 2 r to the n minus 4 times x squared. Okay, this is the first term. But you see the second term, this is plus, I should write the term containing y now. So this becomes r to the n minus 2 plus this is n minus 2 into, this is r to the n minus 4, but not x now, it is y square, because it was a summation, right? So now I expanded the summation. So plus the last term is r to the n minus 2, r to the n minus 2 plus this is n minus 2, n minus 2 into r to the power n minus 4 into, this is, you can see this is z to the power 2. So we got first term as x square, second term with y square, and the third term with z square. So that's what we get when we expand the summation. Okay, so this means, now let us try to add the terms. Alright, there is a n outside into, see, there is r to the n minus 2 plus r to the n minus 2 plus r to the n minus 2. There is that we are having 3 r to the n minus 2 terms. So this is 3 times r to the n minus 2 plus the next term, you can see that there is x square, y square, z square. All the three terms have the one common term, that is n minus 2 into r to the n minus 4. This is common. Should be multiplying this with x square plus y square plus z square. All right, so you can see that this is equal to n into 3 times r to the n minus 2 plus n minus 2 into r to the n minus 4. What is x square plus y square plus z square? Simply go back and check. Right, we already have proved that the x square plus y square plus z square is nothing but that can be replaced simply by the term r square. So now what we do, we simply apply that. So I can see that there is a x to the power x square plus y square plus z square over here. So that I am going to simply replace by r to the power 2 or r square. So you can see the term containing r can be clubbed together now. So this is 3 times r to the n minus 2 plus this is n minus 2, right, into r to the power, there is a n minus 4 plus 2. Minus 4 plus 2 is minus 2. Okay, now I can see that in this term I can take out n as it is. There is 3 plus n minus 2 inside this bracket, and I have r to the n minus 2 common. I'll take this out. So this means n into 3 minus 2 is 1. So this is n plus 1 into r to the n minus 2. So if you see that this itself is the RHS of the question. So hence we have proved the required identity. Okay, then let's go to another question. So in this question, we'll prove this. So 5 is equal to 2 times, this is x cube y square into z to the power 4, right? Uh, then part A of the question, find the divergence of, this is grad phi, and part B of the question, show that del dot del phi is equal to del square phi. Okay, we need to prove this, and we need to find out the divergence of grad phi. Then we need to prove the del dot del phi is equal to del square phi. Okay, so let's start the proof in this fashion. We'll start with the phi. So first we need to calculate what is a grad phi. Grad phi is nothing but, we know that, mathematically denoted as del phi. So what is that? This is equal to dou by dou phi by dou x into I cap, plus this is dou phi by dou y into j cap, plus dou phi by dou z into k cap. So this implies the del phi is equal to, I need to differentiate the given function with respect to x, right? So 2x cube y square z power 4 becomes 2 into 3, that is 6 times x square y square z to the power 4 into I cap. Then the next term becomes equal to, differentiation with respect to y gives me 4x cube y into z to the power 4 j cap, plus differentiation of the term with respect to z is going to generate 8 into x cube y square into z cube into k cap. So this is the del phi. Now what they are asking us to find the divergence of this, right? So the divergence of gradient of phi, right? So denoted by, this is del dot the del phi. So that is equal to del dot, in the sense this is dou by dou x into I cap, plus dou by dou y into j cap, plus dou by dou z into k cap. This is the del dot, the answer which we got just now, right? So that is equal to 6x square y square z to the 4 into I cap, plus this is 4 into, this is x cube y z to the power 4 j cap, plus this is 8 x cube y square z cube into k cap, right? So this is equal to, partially differentiate first term with respect to x, second term with respect to y, third term with respect to z. So this means 6 into 2, so this becomes 12 into, this is x into y square z to the power 4, plus the second term with respect to y gives me 4x cube into z to the power 4. Then we have the last term, that is plus differentiation with respect to z. So there is a z cube becomes 3z square. 3 into 8 is 24 times x cube y square into z square. is this answer. Okay, now we need to prove that this answer is also equal to, let's call this is equal to 1. Now we need to calculate the del square phi. So del square phi is nothing but I need to apply the dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square. Right? So let us apply this now. So first you find the dou phi by dou x. I'll write the phi over here once just for my reference. This is equal to 2x cube y square into z to the power 4. So differentiate, first you differentiate this. So I keep one of the dou by dou x here into this term. So when you differentiate this, it becomes 6 into x square y square z to the power 4 plus 1 dou by dou y I retain and the second one I differentiate. So this becomes 4 into x cube into y into z to the power 4. So differentiation of the phi with respect to y once. I need to do this twice. So I retain one of the doughs out, dou by dou z of differentiate this term with respect to z. You get 8. This is x cube y square into this is z cube. So this means I need to differentiate this once again now. So this is 6 into 2, so that is 12 x y square z to the 4. Second term plus differentiation with respect to y gives me 4 x cube into z to the power 4. And the last term becomes dou by dou z. So 3 into 8 is 24 into this is x cube y square z square. Right? I'll call this as equation number 2. So you can see that 1 is equal to 2 indicates that whatever they have asked, right, we got the answer. Okay, then let's proceed to the next question. So here, if say vector f is equal to x into I cap plus y into j cap all divided by this is x square plus y square, right? If this is the case, show that the vector f is solenoidal and irrotational. Okay, so how do you prove that a given vector is solenoidal? If you want to prove that solenoidal, we need to show that the divergence of this vector is 0. Okay, so I'll write a note here. So if divergence of vector f is equal to 0, this implies the given field f vector is solenoid. At the same time, you need to check this. If the curl of this vector is 0, then you can say that this particular field f is irrotational. So in order to prove that the given particular vector is irrotational, right, we will be checking the curl of that particular vector. All right, so let's uh, let's do this calculation now, right? So let's start with this. So I need to calculate, in order to calculate whether it is solenoidal or not, first we'll start with the divergence of this vector f. So divergence of this vector is equal to, I need to do del dot this vector f. So del dot indicates that this is dou by dou x into I cap plus dou by dou y j cap, dou by dou z into k cap. This is del dot the given vector. Now you see I split the vector x dot I cap. I just write the x dot I cap here. So that is x divided by x square plus y square into I cap plus y divided by x square plus y square into j cap. Alright, so it's one and same, still the same. Let's define this. So this means I am supposed to perform the dou by dou x of x divided by x square plus y square, plus I should apply the dou by dou y to the second term, that is y divided by x square plus y square. Okay, now let us perform the differentiation here. So if you remember, this is a quotient rule. So quotient rule says that denominator, that is x square plus y square, into differentiation of x, that is 1, minus x into differentiation of the denominator, which is 2x, whole divided by this is x square plus y square. This is the differentiation of the first term. Okay, plus you see the second term, I'm going to differentiate the function with respect to y. So new denominator x square plus y square into differentiation of y is 1 because differentiation happens with respect to y, minus this is 2y into y, I'll write a y square, whole divided by x square plus y square. So you can see that the numerator what we are writing here is, uh, let's expand, x square plus y square minus 2x square. Since the whole denominator is same, I can write the same thing continue. So this is x square plus y square minus 2y square whole divided by this is x square plus y square. So you can see that the numerator terms are something like, I have x square plus y square minus 2x square. So plus x square minus 2x square and x square cancel. Similarly, minus 2y square and y square cancel. So this is equal to 0. So since this is 0, the divergence of this vector is 0. We can say that the given what you call vector is solenoidal. That's the answer. Okay, let's go ahead. In order to check that whether the given vector is right irrotational, I need to start with the curl. Okay, this is curl of vector f. So that is del cross f vector. So how do you calculate the del cross a vector? It is a determinant I, j and k caps. Dou by dou x, dou by dou y, dou by dou z into, you see that we have only the first two terms, that is x by x square plus y square, and this is y divided by x square plus y square, and there is no z term, so that is written as 0. Okay, now this means let us try to simplify this by using the standard method. This is equal to I cap. So when you have I cap, you can see that first term is dou y of 0, which is 0. Second term is dou by dou z of this term. There is no z term over there, so this is 0. So I can simply write I into 0 itself. I don't have to do any other calculation. So this becomes simply 0. I cap into 0. Next, minus j cap into, so I need to do the calculation for the j cap. So you can see that when you use the j cap, I am multiplying dou by dou x into 0, which is 0. Then dou by dou z into this term. Since there is no z term in the differentiation, it still becomes equal to 0. Okay, so j into, that's also 0, plus k cap into, now I have a differentiation because this into this into this, right? So that means I can simply write this is dou by dou x of k cap into, let's write this is dou by dou x of the first term, that is y divided by x square plus y square, minus this is dou by dou y of the first term, that is x divided by x square plus y square. So this is equal to now k cap into, so differentiation of the first term is, now we see that you are simply differentiating with this function with respect to what? With respect to x, right? So this is y is a constant which remains there as it is. Differentiation of something divided by in the denominator is the square of the term, x square plus y square the whole square into differentiation of 2x, right, into negative because it is in the denominator. So this is minus 2xy. All right, then let's go to the next term. There is a minus. Same thing happens with respect to y. So minus of minus is plus 2xy divided by this is x square plus y square whole square. So you can see that they will cancel each other and the answer is 0. Since curl of the vector f is 0, you can call that the given function, given vector f is irrotational. So in order to prove that a given function is solenoidal, calculate the divergence of f and check whether it is equal to 0. If 0, you say that the answer is solenoidal, right? At the same time, you perform the curl of that vector, and if the answer is 0, you can say that the given vector f is irrotational.